yeah, let's get started. All right. So these quadratic number patterns that I am going to do with you this evening, some of them are a little bit more straightforward. Other things are a little bit more difficult. And what I wanted us to do was actually start with something that was a little bit more challenging. Well, some of the questions are a little bit more challenging, and then a couple of the others are a little bit easier. All right. So imagine they say to us, we have a quadratic number pattern and it goes 4p 11q 22, and they tell us that there is a constant second difference of 1. So if you recall, all right, all quadratic number patterns have a constant first difference, have a first difference that's linear and a second difference that is going to be the same or constant. So all quadratic number patterns will behave in that way. That's why they are quadratic. No other number pattern behaves like that. The first thing that they want us to do is show or prove that P is 7 and Q is 16. We're not allowed to substitute in the 7 or the 16. We've got to prove that. So what are your ideas as to how we should start this question? We've got to calculate P is 7 and Q is 16. How would we show that? What do you think? Okay, so find the first and the second difference. Okay, well, they've told us what the second difference is, haven't they? They've told us that there is a constant second difference of 1. So we don't have to find that, but maybe we have to use it. Okay, so Nhlanhla has given us an idea. Unati's given us, okay, so why are you saying 11 minus 4, Unati? You're subtracting the first term from the third term. We can't do that. We can't subtract the first term from the third, or the first term from the third term. And Nhlanhla, you've got 11 minus p minus 4p equals 1. Okay. So let's just put everything down. We've got 4, we've got p, we've got 11, we've got q, and we've got 22. So we know that we find our differences by subtracting the next term minus the previous term. So if this is the first term, that's the second term, that's the third term, that's the fourth term, this is the fifth term. In order to get our first differences, we have to say term 2 minus term 1. So that would be where the p minus 4 comes from. Then, as far as our next one is concerned, it would be 11 minus p. Then the next one would be q minus 11. And the last one would be 22 minus q. All right, now we know that our constant second difference is going to be 1. So this is why Nhlanhla was saying what he was saying in his answer. I don't know if the rest of you saw what he put there. He said, let's take 11 minus p. We're going to subtract p minus 4, and we're going to make it equal to 1. Okay, and Nhlanhla, I'm really pleased you used brackets. This year, when I was marking our school's trials papers, that's one of the things that I had remarked, certainly to my class and to the other teachers, is that the matrics were not using brackets when it was appropriate to do so. So remember, if you are subtracting a binomial, you have to put brackets around it. Of course, we can't work with unlike terms. So saying 11 minus p minus 4 means that we're not working with unlike terms. All right, so that would leave us with 11 minus p minus another p plus 4 is equal to 1. So on the left-hand side, we'd have negative 2p, and on the right-hand side, we'd have 1 minus 11 minus 4. So that gives us negative 2p, and that would give us 1 minus, sorry, I've got a bit of a headache today. I've taken something for it, but my brain is not firing on all its cylinders. All right, so negative
sorry
14.
about
So it's all right. It's okay. So
that.
yeah, just please be gentle with me.
Yeah, sure.
Oh, it's all
Let's
right.
help, guys. Yeah.
One of those things. Okay, cool. So we've managed to prove that P is equal to 7. Now we want to do exactly the same thing with Q. So what we could do now is then work with our 22 minus Q, and we want to subtract Q minus 11. So let's put that inside brackets, and again, that would be equal to our second difference. So we'd end up with 22 minus Q plus 11 would be equal to 1. Let's just go down a little bit. Okay, so that gives us negative 2Q on the left, and here we would have 1 minus 22 minus 11. So negative 2Q would be equal to negative 32. Excellent. So Q would be equal to 16. All right, so we've proved that. So again, guys, you are not allowed to sub in the 7 and the 16. If you do that, you are verifying. You're not proving. And the CAP syllabus will never ask you to verify anything. Is everybody happy with that? Any questions? Would you have known that that was what you needed to do? Got it. Okay. All right. Intercausal, yes. All right. Perfect. No, but I wouldn't, but now I do. Okay. All right, Kalipa. Okay, so remember, when they give you a quadratic number pattern, always set it out in this way, where you've got your terms and then find your first differences and your second differences. So always use that as a starting point for any quadratic pattern. Okay. All right. Now they want us to determine the general term Tn of the quadratic pattern. So who can remember what the general term of a quadratic pattern, what does it, what form does it take? The general term of a quadratic number pattern, what form does that take? Can anybody remember? That's it, and Ntantla, quite right. Yes, Kalipa, perfect. Okay, good. That's it, intercausal. Lovely. Okay, you're all correct. Beautiful. Okay, very nice. So all quadratic number patterns take the form Tn equals an squared plus bn plus c. And we know, of course, that Tn is our output or the value of our term, and n would be seen as our input or the position of the term in the pattern. That's it. Beautiful. Okay, 100%. So in other words, when they tell us to determine the general term of a quadratic number pattern, what they're really asking us to do is work out the values of A and B and C. Okay, so now we know that our pattern, well, we knew this before, but we know that our pattern goes 4. Remember, P was equal to 7. 7. Then we had 11. Remember, we worked out that Q was 16, and then we had 22. So our first differences would be 7 minus 4 is 3. That would be the first term of our first difference. 11 minus 7 would be 4. 16 minus 11 would be 5. And 22 minus 16 would leave us with 6. So this pattern is called our first differences, and it is linear. It's a linear number pattern. Again, our constant difference, or our second difference is going to be constant. So 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. So it's very important to get this structure going when they're talking about quadratic number patterns. Now, the reason why we need, well, at least part of this, is we need to be able to solve for A and B and C. So there are rules that we use that come from the algebra. Can anybody remember what is the rule that we use to work out the value of A? How do we work out the value of A? Can anyone recall that rule? That's it. That's it. Good. Well done. Yes, Akila and Kozo, Nhlanhla, yes, Gugu, perfect. Okay, all correct. So we are taking 2A and we are making it equal to the value of our second difference. Okay, so in this case, we would take 2A and we would make it equal to 1. So let's just do that over here. So we're going to take 2A and we're going to make it equal to 1. So that means that A is equal to 1 over 2. That's it. Good, Gugu. Beautiful. All right, let me just move this over and I can just double check. So Gugu said 3A plus B is equal to 3. Good. And A plus B plus C is equal to 4. Nice. So perfect. Blessing, Unati, you're all saying the correct thing. Okay, then we use the rule 3A plus B. So 3A plus B, and we make it equal to the first term, not the second, the third, the fourth term. It has to be the first term of our first difference. Okay, so we're going to make it equal to 3, sub in our half. Sorry, I need to maybe go down a little bit here. There we go. And then we can solve for B. So this would be 3 over 2 if I'm correct. Yes. Okay, and then as Gugu had said, let's use color again to help us here. We would take A plus B plus C, and we would make that equal to the first term of the quadratic pattern. In this case, it's 4. Well done, guys. So A plus B plus C is equal to 4. Sub in our A, sub in our B, and we can work out the value of C. I'm getting 3 as an answer. Okay, so your nth term in this case is going to be 1/2 n squared plus 3 over 2 n plus 3. Okay. Oh, sorry. What I didn't do, I was naughty. I didn't put in the marks. Okay. So in the case of the first one, I should think there would be an accuracy mark on that, and there should be an accuracy mark on that. I'm not sure where the third mark would go in this particular case. It's obviously not going to be on the answers because those are given. So maybe some kind of method mark on simplifying accurately. Okay, maybe I made a mistake. That's
Sorry,
fine.
teacher.
Everyone's getting
Yeah.
2. Okay, all right, that's fine. Sorry, and here I
Yeah.
am, blah, 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 about the marks, whatever. Okay, sorry, guys.
It's okay.
Oh, I see what I did on my
Yeah.
calculator. Sorry, I pressed a 0 instead of, yes, you're right. It should be 2. Sorry, guys. Quite right. quite right. No, it is 2. So on my calculator, I pressed 4 minus a half and then I minused another half instead of 3 over 2. I
3
minused
over
1 over
2.
2. Yeah, sorry. I didn't look at it carefully. All right, so let's just correct it here as well. That should be 2. Okay, so when it comes to calculating the general term, there's generally an accuracy on getting the first, and then there would have to be continuous accuracy marks on the rest. Because obviously what your B is depends on what your A is, and what your C is depends on your A and your B as well. Okay, but you know that your exams are going to be marked with consistent accuracy marks anyway. So consistent accuracy, just in case you were interested, consistent accuracy marks are really there to try and help benefit you as much in the exam as possible. So it means that if you make an error, you can still get marks for your working. Now, what that doesn't mean is that you can do incorrect maths. You can't break mathematical rules. You can't make statements that are false. You can't assume things. You can't do bad maths. You can't cancel terms. You can't, you know what I'm trying to say? You can't divide by 0, etc., etc. So continuous accuracy doesn't allow you to break mathematical rules. It allows you to add, subtract, multiply, divide incorrectly. Okay, so if you've worked with numbers and you've made an addition error, or if you've made a subtraction error, then you can get continuous accuracy marks. You're not going to get full marks, but you are going to get marks for correctly using your method. Your method is correct, but you just made a number mistake, essentially. Okay, all right, so we've managed to do that. So now they ask us to determine the value of n if Tn equals 232. And of course, if I had carried this through to that, I would have soon realized that I had made a mistake. So because I wouldn't end up with natural numbers. So remember, when you are calculating the value of n like you are here, n needs to be a natural number. That's because we're talking about term number 1 or term number 2 or term number 3 or term number 10. You can't have term number 10.35 or term number 20 and a half. Okay, they have to be natural numbers. So if you end up here factorizing and it doesn't work, or you end up getting decimal places, then you've probably made a mistake in calculating your A or your B or your C. So you can go back and have a look at that. All right, so now we're going to take this 232, which is our Tn, and we're going to make it equal to half n squared plus 3 over 2n plus 2. What's the easiest thing for me to do now in my second step? What should I try and do? What would you guys do? Yes, you want to get it into standard form. Aha. Okay, so into causal. Okay, the rest of you are not incorrect. Okay, you can move the 232 across, and yes, Kalipa, beautiful, you are trying to put it into standard form. So none of those answers are incorrect. But I would do what Ntokozo says, and I would get rid of the fraction first. So getting rid of the denominator of 2 means that we should multiply every single term by 2. Okay, the lowest common denominator. So if we do that, we're going to end up with 464 equals 1n squared plus 3n plus. We're timesing everything by 2, so that would be 4. And now get it into standard form. Okay, so that would be minus 460. Everybody happy with that? Okay. Now, do not stress. What is that? Do not stress about trying to factorize this. don't waste your time, precious time that you need to answer more important questions. If you've got a number like 460 and it's not immediately obvious to you what your factors should be, what can you use straight away that's very easy? If we don't want to factorize, what can we use? Exactly, the quadratic formula. Now, it's not x equals, because you're not solving for x. Good, Tuelo. Good, Gugu. Okay, you are solving for n. Okay, so the rule is that when you use the quadratic formula, you've got to show that you've subbed into it. So many students will now write the formula on the page and then pick up the calculator. Don't do that. Okay, show that you've subbed always. Write first and then pick up your calculator. Picking up your calculator, the first Leanne's already got the answers. Well done, Leanne. Okay, but now hang on a second, because one of them should be positive and one of them should be negative. So we should be able to disregard the negative answer. So we've got negative b plus or minus, and then we've got b squared. So that's 3 squared minus 4ac all over 2a. All right, so two different solutions for n. Okay, now, Leanne, you're getting negative 20, and Mamelo and Blessing are getting positive 20. What are the rest of us getting? Math error. Okay, Yamkela, you should not be getting a math error. Now, hang on a second. Okay, so Yamkela, what I'm going to do is I'm just going to call up, yes, and Tukozo, that's what I'm getting as well. Oh, was that the wisest thing to do? Okay, guys, just give me 1 second. I'm just going to activate my calculator, but I don't think that you guys can, you can't see my calculator right now, hey?
No, we can't.
No, you can't. Okay, all right, just hang on 1 second. Let's just click on, I think I've got to do that. And then you should be able to see the good old calculator. Can you see it?
Now I can, yeah.
Okay. So, Leanne, remember your formula, your quadratic formula is x equals negative b. X equals negative b plus or minus, and then here it's b squared minus 4ac. So this 3, because it's a positive here, it's going to be a negative over there, all over 2a. Okay, so the easiest thing for you to do, you're going to get negative 3, and then you can choose either a plus or a minus. And then you're going to put in your square root. Use brackets, because if b is not negative, it has to go in brackets. Okay, so there's another place where it's always appropriate to use brackets. Minus 4 times 1 times negative 460, and all of this has got to be over, hold on 1 second, here it's 2 times 1, it's not really going to make any difference to the 2, and now we can press equals. So there we go, there's our answer that gives us 20, so we can put our 20 over there. Then the easiest thing for us to do on our calculators is to navigate back. Right, so now I want to go all the way back, and then I'm going to go and change that plus to be a minus. Okay, and there we get our negative 23. Okay, so you guys, most of you were correct. Okay, but n cannot be negative 23. Okay, so you have to disregard that answer. Okay, often what they would do is there would be one accuracy mark on this line for accepting 20 and disregarding negative 23. Okay, so you can't have term number negative 23. Okay, so it is in fact term 20 that is equal to 232 in this case. Let's just go back and see how many marks it was for. 4 marks. Okay, so matrix, a mark for equating. Always a mark on factors or using the quadratic formula. They're probably a mark for standard form as well in this case. Okay, everybody happy with that? No, you can write NA. You will be marked correct. Yes. Yes. Okay, and Takozo, not a problem with writing NA. Okay, so underneath over here, you could just write, instead of crossing it out, you could write not applicable, and that would be absolutely fine. Okay, no worries at all. Cool. All right. So these questions are all quite nice. Now, something for us to think about. That's why I chose this question, because the first few are all right, and then this one is a little bit more difficult. So this is on 5, and it says to us, if the sum of 2 consecutive terms in the pattern is 1,227, calculate the difference between these two terms. So if the sum of 2 consecutive terms in the pattern is 1,227, calculate the difference between these two terms. So let's break this down and try and figure out what this means. We need to be able to understand the question, first of all, before we go ahead and go and answer it. What does this mean? What do they want us to do? Does anyone feel brave enough to unmute and provide a sort of easy explanation for us to understand this question? Okay, now, Lebogang, thank you for your suggestion, all right? I'm going to put that forward to everybody else. Lebogang has said an SN formula. What do the rest of you think? Do you think we could use an SN formula? Any of the SN formulae that we know? Do you think we could use that in this particular question? What do the rest of you think? Do we have an SN formula for quadratic patterns? Yeah. Okay. So, Lebogang, I understand what you're doing here. You're trying to think of all the things that you know when you see the word sum. Okay, and you're trying to relate that to the matric work that you know, and I can understand why you're trying to do that. But when it comes to our matric work, we only have SN formula for geometric patterns and for arithmetic patterns. We don't have an SN formula for a quadratic pattern. So there's no SN formula here, unfortunately, that we can use. When the question says the sum of 2 consecutive terms, we know that the word sum means things need to be added together. So that's perfect, Lebogang. Okay. When they say of 2 consecutive terms, what does that mean? What does the word consecutive mean?
Two terms after each other, miss.
Exactly, Jared. Perfect. So 2 terms that follow one another, one term after the other. Beautiful. Good. So you guys do understand the language of this question. So if we go back and we look at our original pattern, 4 and 7 are 2 consecutive terms, or 7 and 11 are 2 consecutive terms, or 11 and 16 are 2 consecutive terms. Now, obviously, it can't be the first, the second, the third, the fourth, or the fifth term that have been added together, because when we add these consecutive terms, we get a big number, 1,227. All right. Then when they say to us, calculate the difference between these two terms, they want us to work out the value of those terms and then say the bigger term minus the smaller term, that will give us the difference between them. Okay, so in other words, the difference between term 7 and term 4 would be 3. No, the first difference is not going to be, so the sum of the two consecutive terms is 1,227. So two terms in the quadratic pattern add up to 1,227. So we are going to have to work out, their position is not important, all right, but their value is. How are we going to write a term and a consecutive term using algebra? This is actually the hard part. So if one term, let's say a term, it takes the nth position in the pattern, the next consecutive term will take what position? You thinking? Yes, Lebogang. No, it's not 2n minus n, but you're using algebra, which is cool. So if the first, so if the pat, if let's say the first of these two consecutive terms has the nth position, or yes, we could do that, Gugu, we could do that, absolutely. Then that would be the one behind it. Okay. So you could work with that. You could say n minus 1 and n, those would be two consecutive terms. Or you could say n and n plus 1. Does that make sense to everybody? Are we happy with that? Is that okay? All right. So if you're choosing Sure and Tlantla. Okay, so in other words, what I'm trying to say to you is this, okay? If we go back to our original pattern, okay, this is term number 1. So this is term number 2 because it's 1 plus 1. This is term number 3 because it's 2 plus 1. This is term number 4 because it's 3 plus 1. Does that make sense to you? Okay, so if you are talking about the nth term somewhere all the way down here, all right, the next consecutive term is going to have position n plus 1. And then after that would be n plus 2. All right, so algebraically, we could write the positions of these two consecutive terms in the pattern as n and n plus 1, or n minus 1 and then n. It really doesn't matter. So this is what we would need to do. This is going to be a bit of a long one. All right, so it tells us we need to add these together. So let's say we decide, because Tn is half n squared plus 3n plus 1, and we're going to use n and n plus 1. It means that our first term is going to be described by half n squared plus 3 over 2n plus 2. To that, we need to add the next consecutive term in the pattern. So this is going to be half n plus 1 squared plus 3 over 2 n plus 1 plus 2. And these two have to add up to 1,227. All right, the other way that you could choose to do this, hope this is making a little bit more sense now. Now, Gugu, you wanted to use n minus 1. You can do that, Gugu. Let me just scooch over a little bit here. Gugu, if you want to use n minus 1, you could do this. So here it would be half n minus 1 squared plus 3 over 2 n minus 1 plus 2 plus, and then you would use your half n squared plus 3 over 2n plus 2 equals 1227. Okay, so the idea is to be able to describe a term in the pattern and the next consecutive term using n's. Does that make sense now? Okay, cool and Tlantla. Kalipa? Ntokozo? Is that a bit better? You good now? Okay. All right. So there's your equation. Now we've got to solve this massive, horrible thing that has got fractions in it as well. And they can expect us to work with some nasty fractions by the time we get into matric. Okay, so let's do the first one. We're not going to do the second one as well, although Gugu's suggestion was lovely with the n minus 1 and the n. That's perfectly fine. So we're going to bring down our half n squared and our 3 over 2n plus 2. And then inside this bracket over here, we're going to leave the half on the outside and I'm going to square the binomial first. So remember, very important, when you square a binomial, it has to have 3 terms. Okay, so this is going to be n squared plus 2n plus 1. Okay, and then I'm just going to leave that as it is and then remove all my brackets at the same time. So we're going to end up with half n squared plus 3 over 2n plus 2 plus half n squared plus n plus a half plus 3 over 2n plus 3 over 2, goodness gracious me, plus 2 equals 1227. Okay, so let's collect together our like terms. So we've got an n squared term over here and an n squared term over there. Half n squared plus half n squared is going to leave us with n squared. Now we've got our n terms. So we've got 3 over 2n, we've got plus n, we've got another 3 over 2n over there. So that's going to give us 3 over 2 plus 1 plus 3 over 2. Are you all getting 4n? I'm getting 4n. And then let's do our numbers. So we've got the plus 2, we've got the plus half, we've got the plus 3 over 2, we've got the plus 2, and then of course we also want to move that over and make everything equal to 0 as well. So here I'm getting minus 1, 2, 2, 1 equals 0. Okay, please check me. I hope I haven't made any addition errors in this case. You get the same. Okay, Kalipa. How about everybody else? Are you getting the same answers as me? I'm sorry, I'm just going back. It was 1227, so I didn't write that down wrong. You got the same, Akila and Tlantlet. Cool. Thanks, guys. Okay. And again, we're not going to stress. Every time they want us to factorize a nasty quadratic, we're not going to waste our time fiddling on our calculators, trying to find factors or anything like that. We go straight to the formula. Okay. So you just show that you've subbed in. So we've got -4 plus or minus. And then here we've got 4 squared minus 4 times 1 times -1221. And all of that over 2 times 1. Okay, and again, we should get 2. Okay, Mamelo's getting 33 and -37. How's everybody else doing? Mamelo, I'm going to pull up my calculator and it's just go with plus root minus 4a C1221, and all of that is over 2 times 1, which is going to give me 2. So that gives us 33. Cool. And of course, if we go back and we change this, then I should get the same answer as you guys, which is the -37. Are we going to work with the -37? No. All right, so we're going to write NA, or we're going to put a line through the equal sign because N cannot be a negative. Okay, it also can't be a fraction. So it can't be a negative fraction and it can't be a positive fraction. N always has to be a natural number. So therefore 33. Okay, so in other words, we have found the position of the first consecutive term. It is in position 33 in our pattern, right? The next term, the next consecutive term is going to be in position 34. Does that make sense? Because we had n and n plus 1. Okay, so if n is 33, then n plus 1 will be position 34 in the pattern. Does that make sense to everybody? Cool. All right, so n is 33, which means that n plus 1 is going to have a value of 34. 33 plus 1. Okay, lovely. So now we know the position of these terms in the pattern. Now we want to work out what their value is. So we're going to sub 33 into our nth term. So we've got half n is 33 squared plus 3 over 2 times 33 plus 2, and we're going to work out what its value is. And then we've got term 34, and we're going to sub 34 in. And we're going to work out the value of the 34th term. Okay, are you getting, for the 33rd term, are you guys getting 596? Yes, okay, me too. And then for the 34th term, I'm getting 631. Are you guys getting that as well? Okay, and we can do a quick check here. If we add 596 to 631, we get 1,227. Okay, so we're feeling confident. We're feeling confident. And now they wanted us to find the difference between these two terms. Okay, so if you recall, we go back to the question, they told us that the sum of these two consecutive terms was 1,227. They want us to calculate the difference between the two terms. So in other words, what they want us to do is work out what term 34 minus term 33 is going to be. Okay, so the difference that they want from us is going to be 631 minus 596. And I'm calculating that our difference is 35. Yes, me too. Good. Well done, Akila. And Tuelo, good. And Mamelo, beautiful. Good job, everybody. Okay. So that was out of 5 marks. Right, that's quite a lot, isn't it? Okay, so definitely a mark for accurately setting up our equation. I suspect here that there would also have to be a mark for using n and n plus 1 or n minus 1 and n. There's always a mark for factors. And maybe there would be a mark on that and then a mark over there for our final answer. Okay. Any questions before we move on? Everybody happy with that? You're all good. All right. Okay. Well, I'm glad we got to do something that was a little bit more difficult and something that we really had to think about. Good. It's nice to see those thumbs ups from you guys. Beautiful. Okay. All right. So we don't have an awful lot of time left. Amazing how quickly our sessions go. We finished that question. This is something that we should definitely try. Let's get started, and then we may have to stop depending on our time, because we don't have an awful lot of time left. Okay, so let's do this together quickly. All right, so we've been given a quadratic pattern, and it goes 244, 193, 148, 109. What do you notice about these numbers? The numbers up here, these numbers got bigger, didn't they? Went from 4 to 7 to 11 to 16 to 22. What's happening with these numbers? Yeah, they're getting smaller, aren't they? Absolutely. So they're decreasing. Correct. So from 244 to get to 193, remember you're saying term 2 minus term 1. So now, is your difference going to be positive or is your difference going to be negative? Exactly. Your difference is going to be negative. So we need to say 193 minus 244. Okay, so our pattern of first differences is starting off with negative 51. And then we've got to say 148 minus 193. And now we get negative 45. And then we've got 109. And we've got to minus 48. Maybe you guys have already got the answer to the question. I'm getting negative 39 here. Yes, you guys are as well. Beautiful. Okay, so our first differences are negative, but they're increasing. Okay, so from negative 51 to negative 45, that's got bigger. And from negative 45 to negative 39, that's also got bigger because we are getting closer to 0. So that tells us that our constant difference would be positive. Anyway, we're not quite there. We don't need to use that. But how much would we know? What are we going to do in order to get the next term in the pattern? Each of these is going up by how much? By 6, absolutely. Okay, so if we take negative 51 and we add 6, we get negative 45. If we take negative 45 and we add 6, we're going to get negative 39. So over here, again, we would need to add 6. So the difference over here is going to be negative 33, isn't it? Okay, so in other words, to work out what this number needs to be over here, we'd have to say 109 minus 33. Does everybody agree with that? Yes, there we go, 76. Beautiful. Okay, so the next term in the pattern is going to be 76. Lovely. Well done, everybody. Beautiful. And then again, similar question. Determine the nth term of the pattern. All right, so we know now we're going to use our rules. What am I going to make 2a equal to? I'm going to make 2a equal to 6. Beautiful. Thanks, Akila. So if 2a is equal to 6, it means that a is equal to 3. And then I'm going to take 3a plus b, and I'm going to make that equal to negative 51. So b is going to be equal to negative 51 minus 9. So I'm getting negative 60 here. Are you guys getting the same? Yes, me too. And then a plus b plus c, a plus b plus c has got to be equal to 244. I'm getting 301. Okay, so if you do get some really big numbers, it doesn't mean that you are necessarily wrong in this case. Yes, lovely. There we go. So our nth term is Tn equals 3n squared minus 60n plus 301. You know how to do 4.3, where they've said which term of the pattern will have a value of 508. You're going to take Tn, make it equal to 508, just like we did in this question over here, 4.3, where we first equated it, quadratic in standard form, quadratic formula, and then solve. Okay. What I really wanted to try and do with you guys was question 4.5, but I feel as though we're kind of running out of time now and I need to go and change my thingy over. So I tell you what, why don't you screenshot this? And the next time we see each other, we can finish off this question. Is everybody okay with that? Sorry that we're kind of in the middle here, but I'll finish this off with you when I see you on Tuesday.